Hello class. The first molecule that I chose was CO2, or as its name is, carbon dioxide. So the total for the valence electrons, well first, I went based off this group. I color coded mine just to help me. But anyways, um, so I did it off the C. The C is the 1, 2, 3, 4 block. So you put a 4. The oxygen is in the sixth group. Sorry, I said block earlier. 1, 2, 3, 4, 5, 6, 6, and there's 2. So it's 4 plus 6 times 2, which is equal to 16 valence electrons. So now for the Lewis dot structure, for this, I put the carbon molecule in the middle and the oxygens on the sides with a double bond. So starting off, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 valence electrons. So for this, this was a linear, the shape was linear, and the bond for this is 180 degrees. Is also non-polar. The hybridization is sp2, and it has a 0 formal charge. Now going back to the Lewis dot structure, the arrows here indicate that the electronegativity is stronger towards oxygen than it is for the carbons. So that's why the arrows point this way, and that's why the delta sign is S negative sign is for delta and S negative is for oxygen. S negative is for oxygen, S negative for oxygen, and S positive is for carbon. Okay, and now for the visual model, so I did mine with the Sour Patch watermelon that I just had laying around my house. And this is actually some peanut butter bites that my sister makes. So yeah, I just needed something to hold it together. So yeah, that's the molecule right here. Now going on to the second one. The second one is HCO3 negative, or in other words, bicarbonate. For this, to find the valence electrons, you can use the periodic table. The 1 is in group 1, so then the 1 is right here. The 4 would be carbon, so group 1, 2, 3, 4, group 4, as shown right here. And last but not least, the oxygen is in group 6. 1, 2, 3, 4, 5, 6, and times 3 because there's a 3 right here. So the negative, I added it at the end. I'll show you right now. So it's 1 plus 4 plus 6 times 3. So first I did 6 times 3 is 18, plus 4 is 22, plus 1, 23, and then plus the negative charge is a plus 1, so 24 valence electrons. Okay, so going on to the Lewis dot structure, I put carbon in the middle with a double bond. Yes, with a double bond for one of the oxygens, and the other 2 oxygens had a single bond. And from the oxygen to the hydrogen molecule, it had a single bond as well. So 24 valence electrons. So starting here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. The 24 valence electrons. So this is the shape of this was a trigonal. Sorry for my pronunciations. Planar. It is a polar molecule. The bonding was 120 degrees. The hybridization is sp2, and it had a negative 1 formal charge. Now also for this, the the oxygen had a higher electronegativity than the carbon molecule and the hydrogen molecule, which is why the arrows are pointed towards the oxygen. And because it also had a stronger electronegativity, then the delta would be S negative, S negative, S negative, S positive, and S positive for the other two. Sorry, give me 1 second. Okay. Oh, and I forgot to show you guys the 3D module. So for this, it looks kind of like this. So this is a Sour Patch, the peanut butter cookie, homemade cookie, and a piece of a Kit Kat. So the peanut butter cookie would represent the carbon molecule, the Sour Patch, the oxygen molecules, and the Kit Kat, the hydrogen molecules. Okay. So now moving on. Okay. The next one is H2O, or dihydrogen monoxide, or as its simpler terms, water. So for this, to find the valence electrons, the same process. So H2O. So H is in group 1. So 1 times 2, and then plus 6, because oxygen is in group 6, as you can see right here. So this would have 8 valence electrons. Now for the Lewis dot structure, it is I put the O in the middle with a single bond extending to hydrogens, to both hydrogens. So it would have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. This would also be a tetrahedral. The bond angle is 109.5 degrees. It is a polar molecule. The hybridization for this is sp3, and it has a formal charge of 0. Okay. Now, as for the polarity arrows, they would point towards oxygen because it would have a higher electronegativity, which is why the hydrogens are pointing upwards. The delta sign is S negative for oxygen because it's a higher electronegativity, and it's for the hydrogen it is an S positive because it has a lower electronegativity. Okay, so moving on to the fourth molecule, it's PCl3, or phosphorus trichloride. Okay, so for here, it would be the exact same process. We go back to the periodic table. P is in group 5, so 1, 2, 3, 4, 5, group 5. And Cl is in group 7. 1, 2, 3, 4, 5, 6, 7. So as you can see here, I put 5 plus 7 times 3. 7 times 3 is 21. Plus 5 is equal to 26. So 26 valence electrons. Now as for the Lewis dot structure, I put P, or phosphorus, in the middle with chloride on the side. So it would be with the single bond and the 26 valence electrons. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And I think I missed one. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. There we go. Must have miscounted on that. Sorry about that. Okay, so the shape of this would be a trigonal bipyramidal. It would have a 120-degree bond angle. This would be a polar molecule with the hybridization of sp3 with 0 formal charges. Now, as for the polarity arrows, they would they would point towards the chloride as they would have a higher electronegativity. So the delta sign for this would be S positive, S negative, S negative, and S negative. And for the 3D models of both of these, they would look like this. For hydrogen, for H2O, it would look like this. And for PCl3 or phosphorus trichloride, it would look like this. Okay. Now moving on to the last one. For the last one, I put IO5 or iodine pentafluoride. To find the valence electrons, I look at the periodic table. I was in group 7. 1, 2, 3, 4, 5, 6, 7. Okay. And F was in group 7 as well. 1, 2, 3, 4, 5, 6, 7. So 7 plus 7 times 5. So 7 plus 35 is equal to 42. So 42 valence electrons. So for the Lewis dot structure, I would be in the middle with 5 fluorides on the side. So 42 valence electrons are represented over here. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. So 42 valence electrons. The shape of this would be an octahedral. They would have 90-degree bond angles. It would be a polar molecule, and the hybridization would be sp3d2. The formal charge of this would also have a charge of 0. Now for the polarity arrows, fluoride has a higher electronegativity, so they would point from the I to the F, as shown here. 1, 2, 3, 4, 5. And for the delta sign, it would be S negative because of the higher electronegativity. So 1, 2, 3, 4, 5, and S positive for the lower electronegativity. And also, I forgot to mention earlier that all these were single bonds. And this can be represented by the 3D molecule of this. Okay, so there you go. My 5 molecules. Thank you.